So having designed this cylindrical dielectric resonator, now let me just show you how to shift the position of this dielectric resonator. Suppose I want to move this, let me show you the wireframe here, or both of these. Okay. Now, suppose I want to move this to the left or to the right. Okay, like that. So what will I do? I will put it to home itself. I will go to history list, click history list. Now where we have defined the cylinder, see this 36th step, where we have defined the cylinder, just select and double click on it. Now see, all these options are here. Okay, the outer radius, the inner radius, okay, which axis is the perpendicular one, what is the Z range, what is the height of the cylinder, like that. Okay, now this cylinder is now placed at the extreme center of the structure. What we want to do, we want to shift it. Suppose we want to shift towards the right. For example, we want to shift it like this. Now here this coordinate axis is utmost important. See, if we want to shift this dielectric resonator to the right, that means now you correlate this movement with this axis. That means we will be shifting this cylinder towards a positive x-axis. See, the positive x-axis is actually shown by this red arrowhead. Okay. So now the x center is at 0. We will add some positive value to it. That actually indicates some positive shift along the x-axis. Okay. So we will edit this 0 to any value. For example, say 5. For example, we are not changing this y. I mean, we are not changing the vertical positioning. We are just shifting this dielectric resonator along the positive x direction by 5 units. Put OK. Put close. It will show you that the structure is actually updated. Do you want to update? Okay. Now see what happens. See, now it has shown a right shift. So if we would have wished to shift it to the left, that means along the negative x direction, we would have used a negative value for the x center. Now suppose I want to move it up. I want to move it up. Moving up means along the positive y direction. So again go to the history list, define cylinder, this one, double click, this comes. Now it is centrally aligned with respect to the y coordinate. Now I will move it up. That means I will add a small positive value or the required positive value to this y center. Now let us consider y center to be 5 only. 5. Okay. Okay. Close. It is updated. Do you want to update? Yes, of course. Okay. Now see what happens. It is moving up. So in this way, we can actually change the position of the dielectric resonator. Wherever we want, we can do that. Okay. Now let us bring back to the original point only, because that is our reference. So 0, again 0, okay, close, yes, I want to update, okay, again it comes back to the center. Now I will show you what I was talking previously, that if I want to generate an annular dielectric resonator, annular dielectric resonator means it should be ring-like structure. There should be a central hollow portion. Fine. Now let us define it in terms of the cylindrical dielectric resonator only. Now there can be two options. There can be two ways in which it can be done. Let me show you both the ways. Firstly, we will follow that extrude operation. That means we will define a smaller cylinder. We will define a smaller cylinder and we will subtract that particular smaller cylinder from this larger cylinder. That is the basic extrude operation. Let us do that, no problem. Modeling, extrude, escape, extrude profile. So let us give the name DR cylinder small. Orientation will be same, Z axis. Z min should be same, 1.602. Height should be same. What was the height? 7 units. Because from 1.602 we extended up to 8.602. So it was 7 units. So height we will write 7. Okay. Now here if you want to define this X and Y points, basically you will get a square structure. You won't get a cylindrical structure like that. So using this extrude profile, if you want to create an annular dielectric resonator, you can actually cut out a square hollow. You can actually cut out a rectangular hollow from it. Okay. If you want to do that, you can do. Let's see. So we have to define the 4 points. For example, now -4 to 4. Then we have 4 to 4. That means the same dimension of the slot. I mean the central slot on the patch we are giving. Then we will come down 4 to -4, 4 to -4. And finally -4 to 4. Sorry, -4 to -4. Now, what is that which we are cutting out? It is alumina only. So we will not select PEC now. So let's preview. See, this slot is shown. Okay. Now an option comes. What do you want to select? What do you want to do with this selection? See, the smaller portion is automatically selected. This dotted region means it is selected. So what do you want to do? You want to cut away. See, you want to extrude means cutting away, removal. So you want to cut away the highlighted shape. See, these options are all there. Okay. If you want to use a Boolean subtraction, that also you can do. Then you have to select this none. None means you will go out of this window. Again do by this Boolean subtraction and it will be done. But this gives you an advantage. I mean, in one step only it can be done. So we want to cut away the highlighted shape. Okay. So we are selecting this cut away highlighted shape. Then press OK. See what happens. See, the slot is visible. Now if I show you this perspective, you see. See, we are getting this annular portion, a central hollow portion, but the hollow is not in the shape of a cylinder. It is in the shape of a square. Now, if I ask you, or if you want to design an annular dielectric resonator such that the hollow should also be cylindrical, then how can it be done? Then there is another method. Let's show the front surface only. So for that, what I am doing, I am hiding this entire dielectric resonator. So from this defined alumina up to this entire subtraction of shape, I will hide. I don't need it now. Close, update, yes. Okay. So again, we are back to the square one, back to the same patch that we have defined. This is the thing. Okay. Now, in order to generate this annular dielectric resonator, we will start creating the resonator from the beginning once again. So how we did that? Cylinder, select, escape, give the same name, DR cylinder annular. Outer radius was 6 units, we keep it as 6. Now inner radius should not be 0, because imagine an annular ring like cylinder here, a shell like cylinder here. So if the outer radius is 6 units, the inner radius will be somewhat lesser than that, but still it will be there. Okay, because we are not having a continuous structure, an annular structure. So let us see, let us say the inner radius to be 3 units now. I hope you have observed the change where we are changing. The inner radius previously for a continuous dielectric block was 0. Now we are keeping it 3. X center, Y center we are keeping at 0 only. Let us keep at 0 only. No problem with that. Z min again the same logic, 1.602. Z max say 8.602. So 7, height is 7. Okay. Component is 1 only. Again we will load from the material library. Alumina, lossy. Load. Preview. Okay. See. Now let me show you the perspective view. It will be better if I change the color at the beginning only. Material properties, color, yellow. Okay. Apply. Okay. Components. See. An annular dielectric resonator, cylindrical in shape, with the same shape hollow, cylindrical hollow. If I just rotate it to show you, see. Okay. So if we want to generate this type of a structure, this type of a dielectric resonator, then extrude option won't work. Then we have to define this in this way only. Because extrude option basically gives you a rectangular extrude shape. For generating cylindrical extrude, we have to define in proper sense of definition of structures only.